Hello guys, welcome back to narsicloud.com. In our last couple of videos, we've been talking about Route 53 and the basic concepts of DNS registration and what are the components involved when you query for a particular domain. How does that domain get resolved to an IP address, right? We talked about those concepts. And in our last video, we quickly gone through the different sections of Route 53 here. As you see on the screen, on the hosted zones, traffic policies and policy records, registered domains, and resolver, which the VPC inbound and outbound endpoints. So today we'll conclude Route 53 talking about the traffic flow section, where you can create the route the different traffic policies. Um, so before we dive into that, you need to understand the basics of. As you remember, always DNS query involves you query for a domain, and you will have your resolver. Resolver will figure out which IP address that request should go to. Right? That's all. That's all. It's there with Route 53 or DNS registration, DNS query concept. So how does that happen? You can go into the detailed diagram, in my previous videos. But here, just to put a simple diagram, always client query for some domain. So in this case, it could be narsicloud.com, right? So the request goes to DNS resolver, and DNS resolver will talk to different servers. Eventually, it goes to hosted zones, where you define your name server to IP address mapping, and that IP address will get back to the client, and client will talk to web server. Right? That's all it happens. Um, in Route 53, we have different options here. Before resolver gets to the hosted zones, in between here, we can define different types of rules and policies. Depending on the type of the policy, the request will be routed to a particular server, right? So let's take a scenario where you have two servers, right? Let's say here you have one web server, right? So let's draw another one. So in this case, this is gonna be web server B, right? And this is web server A. So requests can be served from web server A or web server B. And who's going to tell that? So when client requests for narsicloud.com, and assume that the narsicloud application is running on both the servers, the same exact copy. But this is in different location. This is in some other location, right? These two are in two different locations. But we need to define a rule. This is one of the rules in the traffic flow. I'll go through those the one by one. But before that, let's understand this. The rule could be when the request comes from this geolocation, all those requests should be routed to web server A. And remaining anywhere, the request coming from anywhere else, that request should go to web server B. What does that mean? Today from USA, I request narsicloud.com. I could define a rule saying, okay, if request is originated from USA, then route that request to web server A. Remaining all other countries to web server B, which means we define a rule right there that depending on the location, we are asking DNS resolver to give us the right IP address. So in this case, how does that happen? When request goes to DNS resolver, here it goes to different rules, and it will give that particular IP address. So when it comes from USA, DNS resolver will give the IP address of web server A. So that's how we configure the traffic policies. So that is a basic concept of traffic policy. It could be geolocation, and it could be something like, okay, route 10% of the traffic to web server B and 90% of the traffic to web server A. So it's the kind of rule. So that's the basic concept of traffic flow. How do we define where exactly does that come into picture? So this is where exactly between the DNS between the request and the resolving the DNS name. That's where the traffic policy comes into picture. So if you go back to the traffic policies, let's go to the diagram. So let's create a traffic policy demo. So here, so what we're saying is you got a request of type resolving of type A. This is the starting point, right? So we're going to resolve for particular IP address. So we can define a traffic policy saying, okay, connect to, see, we have these kind of rules: weighted rule, failover, geolocation, latency, multi-value, answer value, geoproximity. So if you go to the weighted rule, select that. See, you can define, let's say here I can give 90% or 10% of here. It goes to, I can define which IP address that should go to. So right now I have CloudFront distribution. I can give that, and here I can define another endpoint. I can define another endpoint. If you have any website endpoint, or if you have any other value, you can give direct IP address 25 like that. So what does this mean right now is whenever request comes for any domain of type A, if you create this rule as a weighted rule, 90% of the requests will go here to this server. So this is the web server in the diagram. If you remember, web server A and web server B. Consider that this is web server A and this is web server B. So all it's returning is the IP address of this this CloudFront domain, and here we directly gave the IP address, right? So this is one rule. And if you go to the other rule, delete that. Failover, if you have a concept called primary and secondary servers of your application, you can define the primary host would be this new endpoint, and you can give any domain. Here you can give any endpoint. It could be CloudFront distribution, it could be S3, it could be ELB, elastic load balancer, anything. But in my account, I just have this CloudFront distribution. So let's take the same thing for every rule, just for demo purposes. New endpoint, and you give some value, right? Value. What's happening here? Failover rule. Always requests go to this primary address. Just in case if this is not available for some reason, the request will be routed to the secondary. So that's a simple concept, failover concept. If you see here, no health checks available because this is not real one, and it is not configured properly, right? Usually if you have proper endpoint and you'll have health checks involved, you'll see the health checks of that endpoint, so this is the basic rule. So like this, you can configure many rules, and eventually when the request comes, depending on the type of the rule, a particular IP address will be resolved, right? So if you go to the other one, so far we talked about weighted rule and failover rule. Go to the geolocation. So remember, I was talking about a couple of minutes ago, I was talking about the rule where we resolve the IP address depending on where this request is originating from. If it is originating from a particular location, route it to this IP address, something like that. So here, see, I can define location rule, something like this, and I can create endpoint here, CloudFront distribution, and remaining all go here, right? It's the same IP address. So what I'm defining here, if requests are originating from this location, route it to this IP address. Otherwise, all other defaults are route here. So that's what geolocation rule, depending on based on the location, right? And if you go back to the other server, other rule, latency rule. So let's say we are defining one based on the region here, and depending on, let's say if in this region, whenever request originates from this region, depending on the latency, it will figure out which server it can route to. For example, I configured US East here, and you can connect to this new endpoint. Um, it could be your CloudFront distribution endpoint, right? So whenever your request originates from some region, depending on this type of rules, it will figure out what is the best endpoint I can reach out to, so that latency is low. You'll get the best latency. So what is latency? It is the amount of time that takes from originating time and reaching to the server and getting back the response. So it is the whole time it takes request and getting the response. That's called latency. The lower the latency, the best we can say it has a best route. It has taken the best route. So in this case, depending on the origin, the region that you created the rule for latency, it will automatically give you the best IP address which takes less time, you know. So that is the latency rule. And coming back to the other multi-value answer. So here you can give different endpoints, something like this. So it doesn't have any rule kind of here. You can also add another value. So it's just defining, and randomly it just goes to different IP addresses here. And go back to geoproximity. So geoproximity is somewhere similar to geolocation, but it's a little different coming to proximity. So it talks about in a given area, the proximity of this kind of, from this area, if request comes, go here. Otherwise, from this request, go here. So what you can do here is, so that's why I configured this, right? And in the region 2, let's say I take US West Oregon, and this is US East. So you can always see we have two regions here, right? You can always have you can add another geoproximity location. So click on the geoproximity map. See, you got two regions because we configured two regions here. What we're saying is all these the requests from this area, route them to this endpoint, and the request coming from this area routed back to this IP address. You see, you have this bias value here. You can enter something like this, right? See, what I'm saying is I reduced the proximity of the region 1. So only this area, this proximity, the request originating from will go here. Remaining all will go here. So likewise, you can add different geoproximity locations, and the route request can be routed accordingly to your IP addresses. So see how useful this concept is. You can make sure your web applications that's running in your servers in different locations Depending on the traffic that's coming from different users and from different locations across the world, you can make sure that a right server will serve your request. That's what happens when we query for, let's say, google.com. How is it able to serve different millions of users across the world? They have their servers set up in various locations, and a right server is responding to users request depending on their location. So they would have configured lots of rules like this. Then only it's possible. Otherwise, if they have all the servers in one location in the world, and if those servers are responding, the same servers are responding to different regions across the world, different countries, some people will get latency, very less latency, quick response, but the people from countries far away from that location, service location, it will be delayed. So that's where this CloudFront comes into picture, and these traffic rules comes into picture, and that defines the way we configure and create our servers and deploy our applications. So this is the basic concept of the traffic policies. So if you go back to the Route 53 section, you can also see the policy records. I wouldn't be able to create policy records because it requires at least one hosted zone. Demo, weighted rule. Yeah, here I should have saved that. 90 10. And we also give the same endpoint here. Just for demo purposes, I'm giving the same endpoint. So here you create a policy records. So when you create policy record, it requires at least one hosted zone. What is policy record? So when you create the traffic policy, what you're doing here, what you're doing there is you're routing the request through different rule, and you're figuring out which IP address, right? But how does that know the IP address of the CloudFront distribution, the endpoint that we gave, right? It needs to get, the traffic policy has to get that some information from somewhere else. So that's where the policy records come into picture. In the policy record, you give which hosted zone you are creating this policy for, and under that hosted zone, which domain, for which domain you are creating this traffic policy. And that's when the request comes of type record A, depending on the policy record, it gets that particular IP address. So traffic policies and policy records complement each other. So that is the basic concept. The name servers, right? So I mean, this is all talking about at the code level, but and when you look at the console, you will have entries or something like this. For each entry, your domain is connected to this hosted zone of these name servers. You remember in our previous video the name server I was talking about? These are the name servers which will give that IP address back to the client. So this is about Route 53, and usually in our companies, unless you are working in cloud, in cloud engineering space, you wouldn't get a chance to create these routes by yourself. Your team will be given of those accounts by a cloud engineering team. And as a web application developers, you worry about developing the application, and infrastructure will be provided to you, but you have the opportunity to use this and requests if any modification needs to be done, and you will be developing, I mean, depending on your role, you will be dealing with the different kinds of services in AWS. That's all, guys, for today. In the upcoming video, we'll talk about another service, which is API Gateway. So that will conclude most of the things under networking section. And that's it. If you like this video, please click on like button, and do subscribe. You'll get to see a lot more videos like this. and on different cloud systems, AWS, Azure, GCP, and different kinds of programming languages as well. Okay, see you guys later. Take care. Bye.